Okay, so as mentioned, there are two types of bonding. One is ionic bond, which is formed between a metal and a non-metal. So previously examples have been given. Sodium plus oxygen can form an ionic compound, which is sodium oxide, where the sodium is the metal, so it will form the ionic compound. How it forms is by transfer of electrons from the metal atoms to the non-metal atoms. The next one is a covalent bond, which is formed between non-metals. So example, when water is formed between hydrogen and oxygen, both which is non-metals, is formed by sharing of electrons between the non-metals atoms. Ionic bonding is formed between a metal and a non-metal. This bond is formed when a metal atom transfer electrons to the non-metal atoms. The reason why this transfer of electrons is occurring is because the atoms want to become stable noble gas. So to have a stable noble gas configuration. Okay, before they were actually reactive because they have the extra electrons. Then after transferring of the electrons, it becomes stable. So I'm going to give you an example. Okay, sodium fluoride that has a formula of NaF. So for any of the drawings of dot and cross diagram, refer to the periodic table and check the proton number. The proton number of 11 from sodium will give you a configuration of 281, and fluorine has 9, which will give you 27. Okay, so this is the first shell. This is the second shell, which can have maximum of 8. First shell can have maximum of 2. And that's the third shell. So the symbol right in the middle, Na, okay, and draw the electrons in pairs. Then you see the last shell having the extra 1 electron. So what I have drawn here is sodium atom, okay, which has a configuration of 281. So for fluorine, I'm using this purple ink. The first shell has 2 electrons, which I will represent with a dot because it is from a different atom. So filling up electrons will be north, south, east, west, and then from one side, one direction. So you will have one of these electrons not filled in because there's only 7 in the last shell. So fluorine have a configuration of 2, 7. So these extra electrons in sodium makes it super reactive, and it will transfer to fluorine by losing 1 electron. So sodium transfer 1 electron to fluorine atom. This causes sodium to become an ion now because the number of electrons and protons are no longer the same. And fluorine will become a fluoride ion. Okay, because now gain an additional electron, so it's more negative. But both sodium ion and fluoride ion now have an octet configuration, which makes them stable. So what does the word octet means? Okay, octet means having 8 electrons in the valence shell, which means there is 8 valence electrons, and this is a stable noble gas configuration. Now, losing that 1 electrons, there's no longer the third shell. So I'm erasing to show the loss of this 1 electrons. And we'll add it into fluorine atom. Now that sodium has 11 protons and 10 electrons, sodium is now positively charged by an additional 1 positive proton. For fluorine atom, it has gained 1 electron. So this makes it a fluoride ion with 9 protons and 10 electrons. The charge is now minus. So this is the final drawing. If the question asks for, draw a dot and cross diagram to represent or to show the configuration or the bonding between sodium and fluorine or in sodium fluoride. So just to let you be very clear of all the different types of electrons, cross represent the electrons of sodium and dots represent the electrons of fluorine. So let's practice. The question is, draw a dot and cross diagram to show the electronic structure of calcium oxide. You can now pause the video and try to do the drawing. Once you're ready, you can play the video again to check the solution that I will explain. Welcome back. So, let's take a look at the solution that I've prepared. First, although we are doing ionic bonding, always check that calcium is a metal and oxygen is non-metal in this question. Okay, just to make sure that you are doing the right drawing in the examination. From periodic table, calcium has the configuration of 2882 because total of 20 electrons. Oxygen has an electronic configuration of 26. So calcium will lose 2 electrons so that it becomes stable with 288. This makes calcium 2+ because of the additional 2 protons compared to the electrons. Now calcium only have 18 electrons left, although the number of protons remains the same at 20. Oxygen will gain that 2 electrons that calcium has lost and form a charge of 2- with the electronic configuration of 28. This ion now has 8 protons and 10 electrons. I'm drawing in the calcium first shell and calcium second shell and calcium third shell. Now you just want the final drawing, so I'm not drawing the last shell. So put in all the crosses for calcium to represent all the electrons. First shell 2, second shell 8, and third shell 8. A shortcut will be immediately bracket calcium ion and indicate the charge of 2 plus. Note that you have the number first, then followed by the charge. Now I'm drawing in 2 electrons in the first shell for oxygen. Second shell, let's fill in north, south, east, west first. Then start anywhere and go in one clockwise direction or anti-clockwise direction. After you're done, don't forget to add in the electrons that are coming from calcium, which are 2 crosses. And finally, bracket and add in the charge of 2 minus. So I'm writing in the legend now. The cross represent the electrons of calcium. And the dot represent the electron of oxygen. Okay, that's it. This is the final answer. Okay, you just need to show the final drawing of the dot and crosses. Whatever workings that I've added in is to help you with the understanding. Now, take a look at the following practice. Draw a dot and cross diagram to show the electronic structure of magnesium chloride. Pause the video now and practice. Once you are done, play the video from here again. Now that you have finished practicing, let's look at the answer. As of any question, always check that you have a metal and non-metal before attempting to draw the ionic bonding dot and crosses diagram. So check the periodic table and look for the proton number. That will give you the electronic configuration of 282. And this means that 2 electrons will be lost to get 2,8 configuration, which is now stable. Chlorine has 17 electrons, so 287, and it will gain 1 electron to become chloride ion, which is having a configuration of 288. There's some shortcut to do for this question. So take note that magnesium atom will lose 2 electrons, while the chlorine atom will gain 1 electron. Hence, you actually need 1 more chlorine atom to gain 1 additional electron from the magnesium. I will illustrate this with a shortcut method where you can just draw the magnesium ion and chloride ion first. So I'm drawing the first shell, second shell of magnesium. 2 electrons in the first shell, 8 electrons in the second shell. So magnesium ion has a charge of 2 plus. So I am just drawing the ion of magnesium first. Next, the drawing of chloride has 3 electron shells. So first shell for chlorine has 2 electrons, 8 electrons in the second shell, and the third shell has 7 of its own and a dot that represents electrons from magnesium. chloride has a charge of minus. Now, need one more chlorine to balance. So a shortcut method without drawing the whole chloride ion again is to add a 2 in front of the chloride ion. The dot represents electrons of magnesium, and the cross represents the electrons of chlorine. Take note, the charge balances. Magnesium 2 plus and 2 chloride ions makes this whole ionic compound neutral. Finally, last practice for today's video. Let's practice. Question is, draw a dot and cross diagram to show the electronic configuration or structure of sodium oxide. You can now pause the video and go ahead with the practice. Play again once you're ready to review the answers. Now, let's look at the answers. Once again, sodium is a metal and oxygen is a non-metal, hence this is an ionic drawing. Sodium has a configuration of 281 and it will lose one electron to have a configuration of 28. As for oxygen, the same thing. 2,6 electronic configuration, gaining 2 electrons to form an electronic configuration of 2,8. First shell of sodium, there is 2 electrons. Second shell of sodium, there is 8 electrons. Oxygen has 2,8 configuration, north, south, east, west, and the rest of the electrons in one direction. And 2 electrons are gained from sodium. So take note that sodium ion is formed after losing 1 electron. So add in the brackets and the charge. Take note, we need 2 sodium atoms to provide 2 electrons. So one way is to check the charges. Oxygen has a charge of 2 minus and sodium has a charge of plus. You need 2 plus to balance 2 minus. So there must be one more sodium ion. So hence there's a bracket of sodium ion with a 2 in front. So this is the end of all the practices that we have for ionic bonding.